12:01, so we can go ahead and get started. Thank you, everyone, for coming to our virtual workshop on field data management solutions. This is our second to last cyber seminar in the virtual workshop series. Today we have Mark Servilla and Duane Costa from LTER, and they're going to present the provenance-aware synthesis tracking architecture. Next week, we have Anthony Oftenkamp from the Stroud-Water Research Center who will give a presentation. And then the virtual workshop series is going to culminate with a virtual poster session on Thursday, October 30th from 12 to 2 p.m. Eastern Time. We have about 8 poster presenters lined up who are going to give short descriptions of their field data management techniques and then open it up to a discussion period. We also have vendor presentations from Kisters and My Observatory. So with that, we'll let Mark and Duane go ahead and get started on their presentation. Mark is the lead scientist for LTER's Network Information System, the NIS, and is a member of the research faculty at the University of New Mexico. Mark holds graduate degrees in Earth and Planetary Sciences and Computer Science, both from the University of New Mexico. Duane Costa is a Network Information System Analyst and Programmer and has been with the LTER Network Office for 11 years. He holds a Master of Science in Computer Science from the University of Rhode Island. So Mark and Duane, if you want to go ahead and take it away.
Great, thank you very much, Emily. So we're going to actually talk about cyber infrastructure here. Unfortunately, it's not going to be about field work itself, but I think you'll find this to be a very interesting perspective in terms of how we manage data at the LTER network. So the talk itself is actually broken into 4 main sections. The first part of this is going to be a little overview about LTER, some of the history of the LTER information management and history of the PASTA framework itself and how that came about. The second part about that will be a little bit about PASTA design, and we'll probably limit the amount of technical discussion just to keep it at a higher level. And then I'll talk more about the benefits that PASTA delivers to, from a user's perspective, and that's both either the data producer and the data consumer, so the benefits to those groups. And then the last part of the presentation, Duane is actually going to provide somewhat of a static demo of the user interface that we have for the PASTA framework, which we call the LTER NIS data portal. So with that, let's go ahead and get started. The first slide, because it is a cyber infrastructure talk, I thought I'd put at least one pretty landscape picture in. This is one of my favorite artists, Trey Ratcliffe, but this is the only real pretty picture that you'll see in the entire presentation, so enjoy. Next slide, let's see. So a little bit of history about LTER itself. So the program was established in 1980 by the National Science Foundation. It's been in existence now over 30 years. Most of the LTER sites have been collecting data long before they actually became an LTER site. So they're combinations of other entities that are involved within the site itself. So some of the sites have been collecting data, for example, Andrews, for 100 plus years. Currently, there are 25 active LTER sites. To date, there are 29 total sites that have existed, so 4 in the past that are no longer operational. LTER has basically 5 separate research themes that they focus on. So it's studying spatial and temporal distribution of populations selected to represent trophic structure within the ecosystems, the study of pattern and control of primary production, the study of movements of both organic and inorganic matter, that counts as 2, and then finally the study of the disturbance patterns within the ecosystems themselves. So a little bit history of the LTER information management. So in the early days of LTER, the information management was primarily localized and somewhat ad hoc. Data discovery and sharing was primarily word of mouth or through personal requests to individual PIs or to the site itself. And that kind of transitioned in the late 1980s into kind of a consolidated publication that came out yearly. It was a paper publication called the LTER Data Catalog, So this is the first time that all the content, the corpus of the LTER data was together in one publication. So it facilitated data discovery, but the sharing of the data was still through that, personal interaction by making those requests. During the same period, there were a group of information managers from LTER sites and a number of PIs that began this vision of a network-level information system. And that vision has been evolving and been worked out over 20 plus or minus years since that point in time. The paper publication transition, as LTER started to embrace the internet, there was a group of information managers that pulled together what was called the data table of contents, and this was the first online capability showing, brief metadata of the LTER data corpus. But it didn't actually provide the direct links or anything like that to the data itself. So data at that point was still based on personal requests to the site information manager or the PIs to obtain that data. But at least now there was a much broader audience that was being accessed through this online data table of contents. But during that same period, there's some overlap there. So the end of the 1990s, LTER was part of a project called the Knowledge Network for Biocomplexity. And from that project came two products. It was the Ecological Metadata Language Standard and the Metacat XML database. And together, those two products provide a much richer source of science metadata on the internet. So that was now available to a much broader audience with a much richer science metadata capability. And within that science metadata, there was also the capability to provide online links to the data that made it, in theory, a lot easier to access that data. Unfortunately, a lot of those links, however, went to site landing pages. They always took some, the end user off the data catalog itself onto the site website. And it was often the case that you had to re-register, or there was a new framework that you had to navigate, navigation to trying to find that data. So it somewhat left the user somewhat encumbered in terms of accessing direct access to that data. The LTER Metacat has been in existence for quite some time now. It's approaching, almost 14 years that we've been using the Metacat. And then there was a kind of a significant milestone point at the LTER 30-year review. Bob Robbins did an investigation as to determine the accessibility. How feasible was it to access LTER data easily through the LTER data catalog, this Metacat? And it turns out that it wasn't that easy because the inconsistency of how those links brought people to the actual site and the accessibility of that data. And so that was kind of a sobering moment, I think, for LTER information management. We did a lot of soul searching and realized that it provided a lot of motivation for change. So I kind of want to end this slide there, and just a note that PASTA was released in a production state in 2013, so just kind of keep that in your mind. The next slide, this one graphic here just indicates that there were still barriers to access LTER data, and we had to really do something about that because it was becoming an issue not only with our community of scientists, but with the National Science Foundation. It's kind of on a similar track then in terms of time. As I mentioned earlier, the information managers from sites and the PIs had this vision of this network level information system back in 1994. Part of that process was the development of this committee called the Network Information System Advisory Committee. They provided a coordinated vision in terms of what we should be doing in terms of our future infrastructure for making LTER data available to the broader community. And that whole process, NISAC is still an active committee today. They still provide a lot of guidance in terms of the direction we take. But that was, the core emphasis on that was, between 2003 up until around 2009, 2010. So in 2006, there was a project called EcoTrends, which took a lot of synthetic data. It was just kind of these derived data sets from a number of LTER sites and some non-LTER sites, and coalesced it into a single package that provided a lot of these time series data and made them available. And part of the LTER network office, we developed the cyber infrastructure for Ecotrends, and that kind of provided the groundwork for the development of PASTA itself. It kind of provided us that baseline information for developing a new cyber infrastructure for LTER. And kind of, you know, the theme here with PASTA, you can see that Ecotrends was somewhat the anti-PASTA of PASTA itself, or the network information system. The work for PASTA itself began in earnest in 2009 with renewal for a cooperative agreement, and we also at that point in time had an award through the American Recovery and Reinvestment Act. So it provided us for the first time and through the network office funds to focus on this new network information system. So in reality, you know, work really didn't begin until the end of 2009, early 2010. So through that period in time, the first year and a half, we spent a lot of focus on the design of PASTA. We followed somewhat of a modified, if you're familiar with software development process, the Rational Unified process. It was kind of a hybrid of that included somewhat of an agile approach to software development. It was very iterative and incremental in terms of progression. In 2010, we actually started releasing some prototypes of implementation. So between 2010 and 2012 was our main emphasis was in the implementation of PASTA itself. And then during 2012, we had a midterm review from the National Science Foundation. And the recommendation from that review, including from the review committee itself, was that we were so far along with the design and implementation that we should release PASTA in its current state. And this occurred then in January 2013. We had the first production deployment of PASTA. This is, you know, roughly about 2 years ahead of what we were planning on releasing PASTA, so that was quite an achievement for us. And since 2013, we've gone through a series of refinements. We're looking at new requirements. We're, you know, doing bug fixes and looking at performance tuning. So we're continually refining PASTA itself. The next slide is the PASTA design principles, and there are actually a number of different design principles, but I think these three are the ones that kind of come to mind as some of the most important ones that we worked with. First and foremost, PASTA itself was a community-driven design, and what we mean by this is that we got the LTR community directly involved in providing us design feedback, and when we released initial, you know, prototype of the applications, they were testing and providing us feedback on the testing itself. And it's kind of actually interesting, and I'm getting ahead of myself a little bit, but PASTA, the original design of PASTA had 9 components, and each one of those components had a Tiger team assigned to it. And these are short-lived Tiger teams. They provided us, we had weekly meetings, if not more frequently, and they generally lasted perhaps between 6 and 8 months at a time, and they were small groups. And the image to the right is just one example of some of the virtual meetings that we had with the Tiger teams. But those 9 components, we mapped those to each one of the members of the Fellowship of the Ring, if you remember from the Lord of the Rings itself. So it was kind of an internal code name for each one of those components. So it was really, really helpful to have the community providing us that feedback during the entire process. The other design principle that I thought is very important here is that we had this vision based on that feedback of Bob Robbins that, you know, the data was distributed across the entire network, but the metadata was located in a single point. We realized that for us, it was a central repository with complete data packages was the vision we really needed to succeed at, so that each data package contains a single science metadata document that describes that particular data package, and the requirement that the data now has to be part of that package so that it is accessible as a single package. So each one of the data packages in PASTA has one or more data files associated with it. And then the last principle here is that data packages are strongly versioned and immutable. And what this means is that once a data package is uploaded and stored in PASTA, that the data or the metadata at that point can no longer be changed. You can view a data package as kind of a series or a lineage of perhaps updates. For example, with time series data, this occurs regularly. But to do that, you actually need to upload a new revision of that particular data package so that the previous revision stays exactly as it was uploaded. And this is what we call somewhat publication-ready data packages. And this really speaks to the need for reproducible science, so that we're really fostering that concept of reproducible science here. The next slide talks a little bit about some of the attributes of PASTA, and again, the name itself, Provenance-Aware Synthesis Tracking Architecture. So PASTA itself is an extensible data repository for LTER. In other words, it is a long-term archive for LTER. It's community designed, as mentioned before. One of the requirements that NISAC advised us to approach was this concept of a service-oriented architecture. And briefly, what an SOA is that basically it's a number of independent services that run on the internet that can be kind of coupled together. They kind of come together to form a much broader and more useful application. And as part of that, we have a public-facing ResTful application programming interface, and that's really important. I'll talk about that in a little bit in another slide. PASTA itself is standardized on the Ecological metadata language. I will talk about that in another slide. PASTA supports multiple data formats, and most of LTER data formats to date are tabular in nature. They're comma-separated value files or tab delimited files. But we're beginning to upload a large corpus of spatial raster imagery from the Landsat archive that we have at LTER, which will go into PASTA. PASTA also supports spatial vector and a number of other data. So for example, like audio binary files of audio research and things like that can actually go into PASTA. And then finally, again, the PASTA supports this concept of immutable and version data packages. The diagram on the right is basically the standard software stack for all the services in PASTA. It's primarily written in Java, so it's based on the Linux file system. We have a relational database underneath there, but everything is pretty much Java based all the way up until the web server itself, which is a Apache web server, which then is how other applications and users interact with PASTA. Now, if you view PASTA as a service-oriented architecture, as I said earlier, there were 9 primary components of PASTA. This is somewhat the service topology of PASTA itself. And let me briefly go through these 9 components. There's the gatekeeper is probably the most important component from a user perspective, especially those who develop software that interact with PASTA, because that is the single point of interaction with PASTA. It provides basically that reverse proxy capability, and it forwards the requests to the inner services that run. And you have to recognize that each one of those inner services are basically running on an independent server, and they can scale, with the need of new types of services and things like that. So it makes it very simple in this service-oriented architecture to plug in new services and then to route calls to those services through the gatekeeper. We have an identity management service that provides the authentication capability and the token. Well, we have an authentication token that is used within the system. There's audit and logging for PASTA, so all the interaction with PASTA is logged to a particular server so that it can actually be reviewed and have reports generated. The larger service there is this data package management service, and it actually is made up of 6 other types of services. There's the metadata quality service, and I'll talk a little bit more about that, but it provides basically a review of the data as the data package goes into PASTA. It does some checks on it. There's a metadata management service which parses that metadata and makes that searchable, discoverable. There's a data management service which provides the underlying storage of the physical data objects themselves. There's a query search component which is tightly coupled to that metadata service. We have this thing called a provenance metadata service, and this generates provenance metadata, and I'll talk about that in just a few minutes. And then we also have an event notification service which basically can send out a notification to an end user if a particular insert of a data package occurs. And then finally, it's not quite a service per se, but I always add it in this diagram, is we have a system monitor that always monitors the state of health of PASTA so that we're always getting feedback on to whether or not the system is up if we're running into any problems. When I talk about PASTA as NIS middleware, it really is middleware from our perspective, but it's kind of a big piece of middleware. On the very bottom of that middleware package, you see that we have producer-type applications. Obviously, these are the LTER sites. We have, a number of sites that contribute. They collect data, they document it, create these data packages, insert them into PASTA. But there are also other projects that are not necessarily site-related, but cross a number of sites. So there's like the Ecotrends project. There's Climb HydroDB. And then there's an upcoming project called Veggie that may actually be pushing data into PASTA. But also just generalized workflows, any workflows that anybody wants to, to run within the LTR network, they can generate new data and put that into PASTA. So those are the producer applications. On the other side of that middleware are the consumer applications. One of those consumer applications is the NIS data portal, which Duane will talk about towards the end of the presentation. But we also have other consumer applications. A number of the sites have written their own types of applications that interact directly with that ResTful API. So there's a report generator from one of the California, or the Central Arizona Phoenix site. There's a data package evaluator from the Hubbard Brook site. And then there are a number of workflow tools, which will be discussed a little bit in the demo part of that, from some of the other sites. But there's also the DataONE member node that interacts directly with PASTA that then provides that information back to the DataONE Federation. There's also additional SOA services that live outside of PASTA, but these are also services that are part of LTER. There's our personnel database. There's a scientific unit registry that we pull content from. There's a controlled vocabulary that we use regularly. And then finally, for authentication purposes, we interact with the LTER LDAP. I'm going to transition now to some of the benefits and the features of PASTA. So this list of benefits and features, there's no order to this list. I'm just throwing them out. And I'll discuss each one individually. So there's roughly about 7 or 8 of them that I'll discuss. The first one I really want to talk about is the ecological metadata language. EML itself is a very modular and extensible metadata language. It's highly descriptive within that framework, and it's primarily used for earth and environmental and ecological science. But it's really kind of a misnomer to say it's just an ecological metadata language. It's a very broad use type of metadata language that can be used for a number of purposes. The development of EML actually began in 1998 as part of the Knowledge Network for Biocomplexity. It's still being developed and evolving, so it's at version 2.11 today. It's an open source project, so the community can actually become involved in the development of EML to extend it, to improve it. It's licensed under the GPL version 2 license. It's defined by an XML schema, and I know that that most people are not technically familiar with XML other than the fact that it looks a little bit like HTML, but it is defined by an XML schema. And LTER adopted EML as our official metadata standard in 2003. There's the link there at the bottom that if you're interested, want to find out more information about EML, it's at the knb.ecoinformatics.org website. So EML to us is very important for science metadata. EML itself, like I said, it's an XML structure. It's very hierarchical in nature. But from our perspective, there's a couple of key components that we really want to touch on. There's a top-level component that requires that every EML document contains a title, a creator, and a content. So across the board, all documents have that information within the EML itself. The creator and contact can be an individual or an organization, and obviously the title is the descriptive nature of what you're actually describing with that EML. There are a number of different context types to EML. There's 4 specific context types. There's the data set, which can be broken down into 6 specific type of data sets. There's a data table, spatial raster, spatial vector. There's a database stored procedure and a database view that may be used. And then finally, there's kind of a catch-all which is called other entity. But if it doesn't fit in one of the 5 previous ones, you can use that other entity to provide a general description of that particular data set that you're working with. Now, as I mentioned earlier, the primary data type we use within PASTA is the tabular data, so it fits into that data table. But again, we're beginning to see more of the spatial raster and spatial vector. We don't see much stored procedure or view, and then we do, have a few of those others in there also. The other three context types, the citation is for publication citations and similar types of information. You can describe software applications within EML, or you can actually also describe a scientific protocol. If you have a standardized protocol that you want to document, you can use EML to do that. The third kind of important factor within EML is this access control capability. And what it provides is it allows the editor of the EML to decide what parts of a data package should be visible to the general community. And you can provide different types of access control rules that are applied to both the entire data package, to the metadata, or to the individual data objects themselves. And I'll talk a little bit more about that in some coming slides. The next benefit of PASTA I want to talk about is the RESTful Application Programmers Interface. For us, REST-based APIs really use what we call, basically four of the standard HTTP verbs. If you use the standard web browser, if you're navigating the internet using a web browser, two of the verbs that you use almost all the time are post and get. When you use a post, you generally fill out form variables within that web page, and then you click on a button that says send or something to that effect. What you're doing is actually sending these attributes as parameters to a web server, and you often do that whenever you're trying to query for some specific information. The other verb that is commonly used with a web browser is the HTTP GET. When you're just browsing the internet and you're just navigating links, generally that web browser sends a GET request to that web server, and that web server responds with the new HTML based on the request itself. There are two other verbs that we commonly use within the PASTA framework using this RESTful API, and those are the put verbs and the delete verbs. And you'll often hear the combination of these HTTP verbs used in a term called CRUD, which doesn't sound great, but it just stands for the create, read, update, and delete operations of a particular service. The diagram on the right basically shows you the life cycle of how these API verbs, how the calls work. So if you have a client, whether it be a software program or a web browser, it makes that HTTP request, for example, the GET to a REST web server, and that web server interprets that request. It generates content in the form of HTML or some other type of content, and then it responds back to that client in the HTTP response. So an example of a RESTful web service call within PASTA, this is kind of a native RESTful call. You can see in the URL field at the top that we're calling pasta.lternet.edu. This is a direct call to PASTA. And this is a GET call that we're using here. And what this call basically does is it says, hey PASTA, please give me the metadata for this particular data package, and that data package is identified towards the end of that URL with the knb-lter-nin/1/1. And what is returned in the response is the raw XML of the metadata. And again, this is the EML metadata itself. And this is an example for a fragment of that EML as you would see it as XML. The following slide, however, shows you how an application can turn that XML into something useful for a human consumption. And that's this portal.lternet.edu. This is the LTER NIS data portal that Duane will go into more detail. But this is an example of converting that XML into HTML so that it's much it's easier read by an end user in this case. And this is an example of how an application can consume native XML and make some use of that. So what's the big deal about the RESTful PASTA? So as I just explained here, PASTA itself is that service-oriented architecture. You have a RESTful API around PASTA. The NIS data portal accesses that API and then does things with that information that it gets back from PASTA. But Unlike the old days where we used to scrape the web to actually, create more applications based on the content available through that, other applications can interface directly with PASTA and consume that information and produce new and more improved types of applications based on the content within PASTA. So for example, there's the GCE toolbox that can read not only the metadata, but the data itself out of PASTA directly. There are a number of conversion tools that you can actually read and create import tools based on the metadata, and then going around that circle, and then finally you can see the DataONE actually interacts directly with PASTA. It doesn't interact with the portal, but directly with PASTA. So it makes it much more extensible, much accessible to a broader community. Another benefit of PASTA is the resource-based access control. As I was explaining the EML component there. So these are little fragments that I've just clipped off of the NIS data portal, and it shows you two different examples. The top example shows you, again, the highlight of the blue formatting there of the actual text indicates that it's an active URL, so you can click on that. So you can access the metadata, the report, and then in this particular data package, we have two separate data entities, and those are all accessible to the general public. However, if you want to embargo data, the example below shows that in this case, metadata and this quality report are publicly accessible, but to access the actual data, you do have to log on and you have to be part of that access control list before you can access that data. So PASTA does support these, fine-grained access control. Similarly, PASTA supports a resource-based download control. And what this means is that each one of those individuals, what you're looking at here is the complete data package. You have metadata, you have a quality report, and then you have, in this case, 10 different data objects themselves. And what this means, though, is this resource-based download control is that I can download each one individually. So if I'm only interested in the metadata and say the data that is represented at line number 3, I can download those and ignore the rest of the content for this data package. Or if I really wanted to take the entire data package and download that to my local workstation, we also provide that capability to download a zip archive of the whole kit and caboodle. Another feature of PASTA is this data package quality review. And what this basically does, in essence, there's 3 types of reviews that we provide. So when an information manager creates a data package and wants to upload it to PASTA, it has to pass a number of checks within the system before it's allowed to actually be inserted into PASTA itself. So these checks or these reviews, there's 3 types of them. There's the metadata check, which basically looks at, say, the best practices for metadata. We want to make sure that certain elements are present within the metadata itself. There's a data type of review that looks at things like, is the data URL within the metadata, is that truly accessible? Do we actually get the data when we access that URL? And then there's this thing called metadata and data congruency. And what this checks is whether or not, how well does the metadata actually describe the data? And what we want to make sure is that there's a good congruency between the two, that the metadata actually does correctly describe data itself. This next slide basically shows that based on those 3 types, each one of those quality checks can have, in essence, 4 different status. There's a valid status, which means that the check passes without error. There's also a warned status, which means that there's somewhat of a notable error in there, but it still passes. It's not going to cause any significant issues, but something that should be checked by the information manager. We have an error status, which means that something did not work and it's going to fail to load into PASTA. And then there's also this info, which just basically means that the quality check is looking at some significant type of information. And I apologize for the small print below, but these are examples of the report that comes out from the quality checks, and you can see that they're color-coded, indicating whether or not they're a valid, warn, error, or info. But there's a significant amount of information that is embedded within the report. And we feel that this is one of the key points of PASTA, providing a lot of feedback to the information managers, to those those data producers. And the nice thing about this, let me go back one slide, is the little fragment that you can see up above, it indicates how you actually upload content into PASTA, but more importantly here, that we also provide an ability that an information manager can just run an evaluation of a particular data package. So it's somewhat of a dry run or a pre-flight test of that data package. You're not actually uploading it into a PASTA, and it gives them the ability to review how well their data package would pass these checks. Another key point of PASTA, again, is this concept of strong data package versioning. These clips also indicate that, in PASTA, as I mentioned, that all the versions are available. So in this particular case, this is actually a good point. We have somewhat of a canonical identifying system within PASTA. When you upload a data package, that data package has to have a unique identifier. And in PASTA, the identifiers are broken down into 3 components. So there's somewhat of a context component. That's the KNB-LTER-FCE. There's a unique identifier, which is somewhat of an accession number for that site or for that context. And then the last value, the number 9, is the revision value of that particular data package. So the 9 elements on the right side of the slide shows you the lineage of this one particular data package. So there are 9 different revisions. The revisions values, they just have to be in succession. They don't have to be consecutive, though. So it makes it kind of nice from that perspective. For all data packages that go into PASTA, we provide a digital object identifier, and this is an example of the digital object identifier that you see here. We also provide somewhat of a recommended citation, and by no means is this the only way you would be able to cite that data package, but it's just a recommendation, and just kind of the impetus is to cite these data packages. We use EasyID to provision our digital object identifiers. That's a project out of the California Digital Library, and those DOIs then are eventually registered within the DataCite system as a data digital object identifier. We also provide what we call simple provenance metadata. This is an example, a fragment of that provenance metadata. This metadata basically describes a data package that was used in the creation of, say, a synthetic or a new data package. And the structure of this provenance metadata is EML based, so that EML, this fragment of metadata, can be inserted directly into the metadata of a derived product. So for example, if we have a workflow that's based on, say, in this example, this Arctic data package here, 983.7, I want to generate some provenance metadata so that when I create this derived product, I can embed this provenance metadata into the derived metadata, and I can put that back into PASTA. And PASTA recognizes that as part of this provenance chain. Let me just show you a little bit about what we're talking about here in terms of the provenance chain. So if I have a data package A, and I apply some workflow to create a new data package, say A prime, I can describe within the metadata of data package A prime the workflow using EML, and that would be method step number 1. But I can also describe using that simple provenance metadata within method step 2 that actually points back to package A. So how does this work in the long run? Let's see. So if we have, say, for example, data package P and data package A, and I combine those using some workflow, I can describe those as data package PA. Within the provenance chaining, I can actually point back to those, so I have a record of what data I had used to create data package PA. Similarly, if I have data package PA and another data package S, and I want to combine those into a data package PAS, and if I have yet data package T and data package A, and I want to combine those into data package PASTA, PASTA, I should be able to then, with the simple provenance mechanism, follow the chain back to the originating data packages, in this case, data package P. Another feature of PASTA is what I mentioned earlier, these event subscriptions, and these are based on data inserts or data uploads or updates into PASTA. And these are really important for workflow integration, especially when you have automated workflows that you want to be triggered based on the insertion of a new data package. And it's fairly simple to create these subscriptions. From an end user's perspective, you provide two pieces of information. You provide the package identifier of the package you're interested in, and this is actually a little loose. You don't have to actually use the fully qualified package identifier. So in the upper left, you can see that you can use, so in this example, knb-lter-cap .23.9 would provide you that particular data package and event for that particular data package. But you can also use partial package identifiers to have that event trigger. And the target URL is basically a workflow that would be accessible via the internet. And when that package is inserted into PASTA, it sends a message to that target URL indicating that that has occurred. We also have scalable storage within PASTA. The design of PASTA allows for storage to be added to the system without actually having to recompile software. So it makes it easy to scale to storage not only physical disk, but virtual disk space. And then finally, we also support a gateway to DataONE. We're doing the final testing at this point right now for this particular gateway. And all public content within PASTA will be federated and replicated within the DataONE federation. Standard data package lifeline, this kind of basically the life cycle of a data package in PASTA goes, site collects the data, it's versioned, it's tested. If it doesn't pass the review, then the site has the opportunity to fix the information within the data package. But once it gets into PASTA, it's separated into metadata and data. It goes into its respective stores. We create the DOI within PASTA. That event subscription is fired to anyone who subscribed to that particular data package, and then that data package is synchronized with DataONE. And then the gray area represents really the physical part of PASTA. And then some statistics to date. As I mentioned, we're operational since January 2013. We have a little over 4,000 data packages from sites and 15,400 data packages from the Ecotrends project for roughly around 20,000 data packages to date. Now I'm going to transition and let Duane actually do a quick demonstration of some of the slides of the NIST data portal. Duane?
Thanks, Mark, and hello, everyone. I'd like to spend the next few minutes conducting a short guided tour of the LTER NIST data portal, available at portal.lternet.edu. The NIST data portal, henceforth just the data portal, is a web application that is built and run entirely separate from PASTA. Though as a client of PASTA, it does depend heavily on PASTA's availability. Because the data portal makes full use of essentially all of PASTA's web services, we think of it as a reference implementation of a PASTA client, in that just about anything that can be accomplished using PASTA's ResTful API is utilized somewhere within the data portal. The data portal homepage features a menu of links across the top to access data, to use a number of the data portal's online tools, to access online help, and to authenticate via login. A simple search box near the top of the page is visible throughout the rest of the application, together with a link to an advanced search page. Below the welcome text, we have a recent news section that features recently added and recently updated data packages, and that too is visible throughout all other web pages in the data portal. The end user has various options for finding data. One convenient method is to browse data by keyword or by LTER site. The hierarchy of keyword terms is displayed as an expandable, collapsible tree, with the number of matching data packages shown in parentheses to the right of each term. There are currently some 725 terms in the hierarchy. Search results on these browse terms are refreshed nightly, and interestingly enough, the hierarchy of terms itself is also refreshed nightly. The browse terms are dynamically generated each night from the official LTER controlled vocabulary, which is itself accessible as a NIS web service. The advanced search page facilitates search by a number of criteria: spatial, geographic, LTER sites, subject, creator, organization, temporal criteria, which, as you might imagine, is important for an organization whose name begins with the words long-term, taxonomic criteria, or any combination thereof. Whether discovered through browsing of keywords, simple search, or advanced search, the search results are presented in a simple tabular format with links. Selecting one of the data package links brings us to a summary page where we have access to the full metadata description of that data package, the quality report that was generated at upload time, the individual data tables and other data entities, as well as a complete archive of the data package, bundling all of these data package resources together in a single zip file. In addition, the summary includes the data package's digital object identifier, its PASTA identifier, a link to the data package citation, provenance metadata, as well as a number of code generation tools that can use this data package as input to programs such as MATLAB, R, SAS, and SPSS. The goal here is quick and easy access to a variety of resources and tools that the data portal can supply for any data package. This is the HTML rendered view of the full EML metadata description. I'll just go past this because Mark has already talked about this. The data portal provides a suggested citation format for a data package. The citation includes within it the data package's digital object identifier. The Provenance Viewer tool generates and displays a block of EML metadata that can be copied into other data packages that are derived in whole or in part from this data package. By using this metadata in their derived data packages, researchers can support the provenance chaining that Mark described earlier. Code generation scripts for MATLAB, R, SAS, and SPSS are the product of a group of LTER information managers who have put a lot of effort into constructing workflows for PASTA datasets and are hosted at the Virginia Coast Reserve LTER and the Georgia Coastal Ecosystems LTER and are accessible as web services. As with the hierarchy of terms in the controlled vocabulary, this is another case of the data portal drawing upon combinations of different NIS web services. In this case, it's using the PASTA web services to access the metadata, taking that metadata, sending it as input to the code generation web services hosted at VCR and GCE, and displaying the output returned by those web services. Personally, I think this is a great demonstration not only of how web services can be utilized in a variety of interesting ways, but it's also an indicator of how LTER is operating as a true network with several different LTER sites as well as the network office contributing web services to produce the end product. The data portal provides a variety of other tools that the data package providers, typically but not necessarily LTER information managers, can use to manage the data packages. The evaluate upload interface is typically used by LTER information managers first to evaluate their data packages and once satisfied that they pass muster to upload the data packages to PASTA. For a given data package or a related set of data packages that have been added to PASTA, an information manager can generate reports to determine who's been accessing those data packages over a specified period of time. This screenshot depicts what an access report might look like. For a given date and time, it tells us how the data package was accessed, which specific resources were accessed, and by whom. Oftentimes, information managers wish to evaluate or upload tens or even hundreds of data packages as a batch operation rather than individually. So it's important that the data portal support this mode of operation. This screenshot depicts how an information manager can view the end result of their batch mode evaluate and upload operations. In the drop-down list, you can see that this particular user, Servilla, has performed a number of different batch mode evaluate and upload operations over the course of a 10-month period. Mark can go back and look at the results of those operations to find out which data packages were uploaded, the quality report that was generated at the time of upload or evaluation, which data packages had errors and failed to upload, details about the errors, and so forth. This is a sample data package quality report displaying the results of a suite of quality checks that were run on a data package. The quality engine looks at the metadata, checking for things like adherence to LTER best practices, the data, and the congruency between the metadata and the data. Now, I don't want to be misleading in my use of the word quality here. The kind of quality control that PASTA uses is somewhat different from the kind of quality control on field data that you are more familiar with. Here we're more focused on the level of quality required by PASTA before it can accept a data package, such as checking whether a data URL actually returns some content as opposed to being a broken link. Each row in the table is a separate quality check that essentially says, here's what PASTA's quality engine was expecting to see, here's what it actually found, and here are some helpful suggestions about how to resolve any issues that were discovered. The quality checks were designed by the LTER community, primarily by a dedicated working group comprised of information managers and network office personnel over a 3 to 4 year period. The quality engine produced by this effort is something we view as a significant achievement. It has been shared as open source with the broader informatics community by incorporating its logic and implementation into a Java-based software library called the Data Manager Library. And to conclude, I'd just like to reiterate that although the data portal is just one example of how PASTA's ResTful API can be utilized, it's the most complete example to date. We see it as a web application that provides a good deal of useful functionality for its end users, packaged within what we hope is a simple, attractive, and functional user interface. Given enough time and inclination to do so, anyone interested in interacting with PASTA could build a similar data portal, but more commonly, they'd probably want to build a more specialized application that targets some subset of the PASTA Web Services API, and in fact, there are instances where this has been accomplished, as Mark has already pointed out. For example, a small group of LTER information managers and network office personnel called the Data Package Reporting Working Group designed a web application that focuses on PASTA's auditing services to compile statistics about how many data packages have been submitted by each of the LTER sites over a given period of time, the frequency of data downloads for each site's data packages, and so on. That web application was implemented at the Central Arizona Phoenix LTER site and is currently hosted there. And with that, I'll turn the presentation back over to Mark.
Thanks, Duane. And then finally, just a brief slide on what we're working on right now in terms of PASTA. So we're doing, as I mentioned, final testing of the PASTA GMN DataONE gateway. We hope that to actually go into production within the next few weeks. We're looking at the redesign of the search interface for PASTA. We're moving from the backend Metacat to an Apache Solr Lucene search engine. And then finally, we're also looking to extend the identity management capabilities of PASTA to include communities beyond LTER. And with that, I'd like to conclude and thank you for your time. And if you have any questions, we'd be happy to answer those. Thank you.
Okay, thank you so much, Mark and Duane. That was a great presentation. If anyone has any questions at this time, you can go ahead and type them into the chat box, and Mark and Duane will answer them as they come in.
I guess the presentation covered most of all questions.
It was very thorough, so that's good.
All right. Well, thanks, Emily, for giving us the opportunity to tell our story about PASTA then.
You're welcome, and thank you so much for being here today. And we hope to see you all next week when Anthony Offenkamp is going to give our final presentation in this virtual workshop series. All right, so thank you so much, Mark and Duane, and look forward to seeing you all next week.
Okay, thanks. Bye now.
Bye-bye.